So let's apply what we just talked about with geometric series. So hey, this is nice. Gives us a hint. It's geometric series. In order for us to see it, we need to be able to write it in the form, the sum of a times r to the n minus 1, where n starts at 1 and goes to infinity. So we need to consider that. Well, what is the a value? A value here is 5. And what is the common ratio? What are we doing from one to the next? Well, it looks like we're alternating signs here, so the common ratio is going to be a negative. It looks like we are multiplying the top by 2 and the bottom by 3. So let's see if this does the trick. Is this the sum of 5 times negative 2/3 to the n from 1 to infinity? Sorry, n minus 1. If n is 1, this is first part is 0 power, so 5. Then when n is 2, we're taking our 5 times negative 2/3, we get negative 10/3. Then we multiply that by 2/3. Then we multiply that by 2/3. It looks good. So from here, we have a over 1 minus negative 2/3. So we have a over, looks like 5/3 is 3. So it works. This number was between negative 1 and positive 1. Everything works out for us. So the next question is it convergent or divergent? Well, it doesn't tell us whether or not this is a geometric series, so maybe it is. We may have to do a little bit of work to get this into a geometric series. So can we write it so that we have a times r to the n minus 1? One thing you want to notice is these powers. You've got 2 to the 2n. Now we could write 2 to the 2n as 2 squared to the n. We should probably do that. Then we have 3 to the first minus n. How about we write that as 3 to the first times 3 to the negative n? I think that looks good. Because remember, our goal is to get some common ratio to the n minus 1 power. Since that's our goal, my next step, I'm going to bring this 3 to the negative n. I'm going to make that a 1 over 3 to the n. So I have 3 from the 3 to the first times 4 to the n divided by 3 to the n. Okay, I really would like to have this as n minus 1. So how could we have this be n minus 1? Well, what we can do is we could say this is equal to the sum of 3 times 4 times 4 to the n minus 1 over 3 times 3 to the n minus 1. So here, that's a 4 to the first and a 3 to the first that we've taken out, I guess you could say, because 4 to the first times 4 to the n minus 1 is just 4 to the n. So what does that give me? That gives me, now that's not a factorial, that's just multiplication. That gives me the sum of 4 times 4/3 to the n minus 1. We have a problem here. Our common ratio, r, is 4/3. 4/3 is greater than 1, so this diverges. And that's the end of our problem. We got it to look like a geometric series, so our A was 4 and our R was 4/3. Now that it's a geometric series, we can say it diverges.